Okay, so let's start with one statistics. At least 30%, one-third of GenAI projects will be abandoned by the end of 2025 after the POC phase. This is what Gartner predicted. And they gave 4 reasons: poor data quality, insufficient risk controls, escalating costs, and unclear business value. And what does it mean for us? Does it mean that 1 of 3 of us actually failed last year? But we are still all here. What does it mean to us? Probably you either already see the value of AI in your company, or maybe you hope that you will see it, or your manager sees it.
Yeah, you have your cursor.
Yeah.
Oh,
You just need to click on the mouse.
Yeah, the right one.
This one.
okay. Anyways, so I get it. Cursor is not working, everything is good, but we are still in the AI race. And we all want to see the results, we all want to see the business value immediately. There are new paradigms every week, there are new models dropping every week, things are shifting very rapidly. So I guess shareholders are pushing the boards, and boards are pushing the managers, and managers are pushing you. And finally, I guess you need to do something with that. And maybe you have this temptation to just take a large foundation model, just stuff it with the context, give it a lot of tools, and after all, why not? Why shouldn't I do that? And yeah, it might work for a small POC phase, but when you try to scale it up, strip it to customers, it starts to fall apart. And you know what? We've been there as well. We also tried this, and I guess you already might suspect that we failed. So this is what I made a screenshot back in the days, and this is what you don't want to see probably. Huge costs, 10 cents per simple user prompt, huge error rate, and on top of that, it was also slow. So my name is Kuba, Rohleder. I'm working for Monday.com for a year. Previously, I've been working for Google. You can find me on LinkedIn. And I'm here to tell you a story how we failed and what we've done with it. So I will give you the background of what we were trying to do, how we looked for the solutions, and finally how we built and verified the thing. So you can learn on our mistakes, and if you face the same problem, you don't need to burn money and time, hopefully. So again, we wanted to start building a product, and we created a gut prompt. A prompt with a lot of context, we stuffed a lot of things into it, we gave it a lot of tools, and it didn't work. So while this doesn't work, what could be the solution? If this holistic approach doesn't work, being more specific. This is what we learned, that instead of just stuffing stuff into one big prompt, it's better to have more dedicated, smaller LLM flows. And instead of evaluating stuff end-to-end by hand, it's much better to evaluate it on every part of the system on real-life benchmarks. So Monday.com. Monday.com is a multi-product company, but the heart of our business are the boards. And the boards can be created by the users. They can represent anything, tasks, for example, and the user can define any schema for the board. We don't impose any conventions. There are multiple column types that user can use, and there are multiple ways to represent the same thing. So while this is a very nice, flexible aspect of Monday, it's also kind of a nightmare for us to understand the user content and help them to work with it. So while one user can have a column called status, the other user can name the same thing state. Or they can have even like a crazy matrix of things representing the tasks at the end of the day. And you know what's the hard part of it? The scale. So Monday has a lot of customers. We use Monday internally for everything, starting from IT tickets, services, snacks for the kitchen, but also tracking the sprints and tasks for developers. And I have, I think, access to thousands of boards and hundreds of thousands of items. But from our day-to-day work, only few of them are really relevant. So what we wanted to build on top of that, we wanted to build not just a chat interface, but we wanted to build a system that really can do the work for the user instead of just helping them. Something that can take your multiple projects and summarize them, or create reports based on multiple boards, and can really understand what's your business structure and do the work for you, so you don't have to do it yourself. And to do that, we had to find a way, and this is the name I really like, a minimum viable context. So this is a thing where we can put into LLM just the information it's needed for this one relevant task, LLM or the agent. And to supply that, obviously, the first answer that comes to our mind is search. And in 2026, if you think about search, you probably think about vector search. And this is also where we started. Oh, one thing before I will tell you how we started. For those who don't remember about vector search, I will give you a super short introduction. So the vector search is a type of search where every document is represented by a vector in multi-dimensional space. So if you imagine this is a space, normally the vectors have much more dimensions than 3, but you can put some things into the vector search, into the database. They're represented by the vectors. And the whole idea is that the vectors that are close to, the documents that are close to each other semantically, will produce the vectors that are also close together in this multi-dimensional space. So if I have this set of documents and I have this prompt, probably my vector for the query will land somewhere there. And I will find those two items. So this is, I think you can already see how powerful this is. It doesn't only catches the lexical closeness or the same words, but it also catches the semantic meaning. It can work multilingual, cross languages, and it's a very powerful type of search, which is, I think, powering right now all the search engines. But this is where we started. We also wanted to build that for Monday.com. So back in the days, this was the model that was very, very popular, so we just took it. We just took like the full dimensions, 1,536. The dimensionality is very important. If you don't already know, I will tell you later why it's so important. We took the full precision vectors, so the full float 32 vectors, and we just put it in the vector database. And we launched it for a small subset of accounts. We did the math, and it would be a financial disaster for us to launch it full scale. Why? We have millions of tenants in Monday. We have billions of entities in Monday, and we have hundreds of millions of changes a day. So it would cost us tens of millions of dollars to run it a year. A lot. And the worst part was that it didn't even work very well. So now, if you ever made search, probably you will know the slide, but if you don't, bear with me, it will be intense. We went back to the drawing board, and we started to think about different solutions. So, lexical search, how to configure it. There are analyzers, tokenizers, there is a fuzziness and stemming, vector search, different algorithms, indexing parameters, querying parameters. There are multiple models for embeddings. All of them have multiple dimensions that you can choose from. You can quantize them or not. You can self-host them or use the managed solutions. You need to choose how to textualize the data, what to denormalize of the data, how to do the re-ranking, which models to select, what oversampling factor to choose, how to boost entities relevant to the user, and there is even more: hypothetical document generation, query routing, named entity recognition. It's very intense. So it feels kind of like this to us. It's crazy how to, in this whole multi-dimensional problem, how to find a configuration which both works for the user and makes sense for us financially. And you know what? We were naive, and we started to test those ideas in production stack. And we, again, unfortunately failed miserably. The problem was that our production stack is complex. We have a Kubernetes cluster, we have a set of microservices, we have Kafka streams with millions of entities being pushed. The integration part was very hard. And it took us, and we have OpenSearch as well, so if we want to test anything, we need to create new indices, re-index the data. At scale, it takes a lot of time. So we started to ask ourselves, okay, so if on production stack, every iteration takes us weeks, and it's very slow, and nobody's really happy about the results, how we can find the best configurations more easily, and how to evaluate the quality, and how to get results in minutes instead of weeks. And obviously, we're also lazy developers, so maybe we can find somebody else to do that for us, right? I think this is the developer's dream. So we decided that, okay, we'll just replicate what we have in production, but in Python, locally, in a way where we can define parameters for the search and we can run multiple benchmark sets at the same time and use any metrics and any top K results that we want to compare with. This is what we see as a result. This is like an example experiment. Higher is better in this case. But more importantly, this is what AI sees. And this was the key factor for us. So the idea was that, okay, if we can easily do it, if running it takes seconds, if we have a very strong evaluation harness where the results of the recall, for example, is our main benchmark, maybe instead of doing it by hand, we can make the AI do work for us. So we created, first of all, we started with a simple AI flow with Cloud Code that creates a hypothesis how to improve the search, plans the implementation, does the implementation, verify the benchmarks around the local implementation, and do it again as many times as needed to improve the results. Finally, it can summarize the results. I can come back from the lunch and see what was discovered by the AI. And this loop continues over and over and over again. This was a couple of months ago, but right now probably you know that agents teams are in fashion, so why not to make it even more complex? Why just evaluate one hypothesis at a time? Why not create a Git work tree and evaluate multiple hypotheses at the same time? So we have a system of sub-agents and a coordinator where every agent can create and verify hypotheses on their own, and the coordinator can take a look at different hypotheses, the results, try to merge them and create like a meta-hypothesis on how to improve search. And we do all this evaluation even before we start to code things in production. And this saves us a lot of time. So just to give you an example of, I think, the earliest finding that we had. So I told before about the dimensionality of the vectors. This is a huge problem. The biggest cause of vector search is the memory. Especially right now, the RAM prices are skyrocketing, so it's getting even more pricey. So we wanted to compare how the results would look like if we take a strong reranker and compare the full precision, non-quantized vectors with binary quantized short, so 256 dimensions vectors, and put the same reranker at the end of the flow. And you know what? The results were indistinguishable. Actually, the shorter were performing a bit better, but this is just a small artifact. And what does it mean for us? We have this reduction. So if you can do the math in your head, it's 512 times the lower size. And this is the money. You know how we felt when we see the results? Kind of like this. The biggest driver of the costs were something that we can fix. And you might ask yourself, okay, so you implemented the same thing twice. That's a lot of work, right? Obviously, it's true. It's a lot of work. Or it used to be a lot of work in 2024. Because in 2024, we as developers were implementing stuff, coding, debugging, maintaining it, creating documentation, reminding ourselves how to read the code again after coming back to the project in 2 weeks. And it takes a lot of time, right? Everybody who did an IT project knows that it takes a lot of time. But in 2026, doing stuff just for local evaluation is very easy. The bottlenecks has been moved by the AI coding agents. Everything that I presented to you can be done with a couple of prompts, to be honest. We don't need to verify the results because the evaluation is the result. This is where we take a look at, and we don't need to even read the code, or just we can read it on a very high level. It's not a production code. It's a local evaluation harness. So, lesson learned. We learned, I think, two lessons on two different things. So first of all, AI coding has really moved the bottlenecks in our industry. We don't think about IT projects in the same way as we did in 2024. We are looking for ways to build local evaluation harnesses, something that can be used for the AI and by the AI to do the quick iterations. And instead of doing things by hand and iterating over it on our own, we can just trust the AI agents to do this for us. So they can do all the heavy lifting, and we can just focus on creating hypotheses and thinking about the bigger picture. And the second lesson that we learned is about building AI-based products, really. So we learned that it's not enough at scale to just start with an expensive foundation model. and just put a simple vector search. If you want to make things work at scale, unfortunately, it needs to be more complex than that. And you might ask yourself, if you're having the same problem, is it worth to invest time and money into big foundation models and doing things simply? Or it's more important to build a strong retrieval system first to build a much better context for the LLM? So yeah, let's talk today. If you had the same problems, or if you were thinking about the same problems, if you see how AI has changed how you think about coding projects, how it changed your industry or your business, or if you were building RAG systems and you really want to chat about different parts, the slide where I had a lot of stickers, maybe I missed something, so let's have a talk. You can find me on LinkedIn. There is even a QR code. I hope it works. But you can also find me here and just catch me on the corridor. I will be here for a whole day, so let's have a chat. I'm super curious to learn how you worked in 2026.
Do you have any questions to the speaker? Any? Yes, there's a question.
Cool. So, as a user of Monday.com, say I open that app, Monday.com, how do I get to use this whole flow of data that you built? What's the feature that I then use?
Right, so we were building a foundation of search for different products. So we have multiple products which are right now doing the work for the user. First of all, we have Monday Vibe, which is kind of like a Replit, but inside the Monday. So you can create applications that are using Monday and Monday automations as a database and automation engine. So it can connect like multiple flows that you have, multiple tools that you're using, calendars, emails, all those things together. And this also is tailored to you. So it learns about your work. It can understand like how you are using your stuff to make a better application for you. And we also have a Sidekick product, which is a general purpose helper that can do both like find the answers for your questions, but also do the work for you. And we are like heavily investing into integrating this in every part of the Monday. So you can connect the data, you can connect the flows, and you can use Monday as your infrastructure. And also Monday MCP, by the way. If you want to use it with your external AI agent, there is an MCP. It also has a search, and it also works very well with Monday search.
So any more questions? Right. So thank you very much.